Hello viewers, I am Vipin Singh and my student ID is 40258628. So the topic for my paper presentation is Cross Miniapp Request Forgery. So I'll be talking about the root cause, the attacks and the vulnerability detection. This is the research paper that I'm going to discuss. Cross Miniapp Request Forgery, the root cause, attacks and vulnerability detection. This research paper was published by 3 people from the Ohio State University, as you can see on the screen. So this is a 14-page research paper that they published. So I'll be discussing about everything which is mentioned in the attack. So let us start with the presentation. This is the table of content. So these are the topics that I'm going to cover throughout this presentation. So first I'm going to talk about the introduction. Then I'll be talking about communication between the applications. Further, we'll move on to research objectives. Then we'll talk about the methodologies in the research paper, then the research attributes. Then we have key concepts and few terminologies that we need to take care of before understanding the research paper. Then we'll talk about mini app communication and the types of attack. And obviously we'll be talking about attacking, how we are going to attack. Then we'll go further for vulnerability detection and implementation of the attack. Further, we'll move on to evaluation, the efficiency, and the security case studies. Then I'll be telling you about the related work and the conclusion. Obviously, I'll be switching my screen between the research paper and the presentation. So please be patient enough to understand and correlate both the things. Thank you so much. Let's move ahead. So first, I'll be talking about the introduction. So what is a super application? A super application is basically any mobile or web application that is fully working, that is fully fledged application which provide different services. For example, we talk about an Amazon application. So an Amazon application is basically a shopping application which is available in our mobile phones and on the web application as well. So it is basically a JavaScript code with the help of which we can interact with the Amazon web servers to place an order. So this is how we communicate. So this is basically a super app which provides different services: the shopping service, the financial service for the payment, the verification service to authenticate the user, the shipping service. So these are all the services which are included in our super app. Other than that, what is a mini app? A mini app is basically a fully fledged application which is executed inside a mobile super application. So basically the super app is the parent and mini application is the child. So what happens is it runs inside the super application. It is a mini app is also a JavaScript code that runs inside a super application, and it just saves our time and development tactics. Just to save everything, we use a mini application. It is basically light in weight and it is executed inside a super application. It has its own benefits and like it has its own pros and cons. So I'll be discussing about them further. For example, if I give you an example, we have the WeChat application. The WeChat application has many small applications, the mini applications that they have. So WeChat is basically a super app and it has more than like 25 lakhs mini applications. So these are basically the services that are inculcated inside the WeChat. So we'll be discussing about it further, its pros and cons. So let's move ahead for now. So what is the importance of using a mini app? So basically a mini app is a very lightweight and fully fledged application. So what happens is they do not require a backend server to communicate. So it saves a lot of money for us. Instead, they require a set of well encapsulated APIs. So they communicate using APIs. They do not go to the backend server. They don't require a backend server. They only communicate using the API. So it is very cheap to run a mini application. If we talk about a developer's perspective, then it reduces cost, the development cost. So it is very cheaper to produce and to launch a mini application. Other than that, users have convenient access to variety of services. Inside one application, we have many applications. So it becomes very user-friendly for a person to interact. And because of this, it gains popularity very frequently. For example, the Snapchat application that we have. Snapchat has a lot of filters inside it. Snapchat is basically a chatting application, but it has a mini app which provides services to change the filters. So that's how it works. Mini apps may not only communicate with their backend as in traditional web app, but also need a similar cross mini application communication. So is it the new feature? Yes, we can say that mini application is basically a new feature, because inside a bigger application, a super application, we have a lot of applications. So it will be easier for us to communicate, to develop application, and it's really user friendly. So moving ahead, communication between applications. So need for communication. So why do we need to communicate? For example, if I have the Amazon application inside my phone and I want to place an order. So to place an order, I need to make a payment. So an application, the Amazon application is a shopping application. It's not a financial or payment application. So it needs to communicate with another financial or a payment application so that it can receive payment from me. So what happens is the communication is required to join different features. So that's why we need to communicate different applications. So super apps basically communicate using an IP. So that's how they communicate. They have an IP table set, and because of which they can communicate easily. It's easier for them to communicate. But in case of mini application, we do not have any IP or any ID. So what we do is a global app ID is generated by the super application, which we give it to the mini application, and using the global app ID, the mini apps can communicate in between. So that's how a mini application works. What happens is when a mini app initiates a redirection request to another mini application, it sets specific data to be transmitted to the other application by setting a special native application intent like JSON objects. So what happens is to initiate a redirection request, it needs to send some data from one mini application to another mini application. We basically call it an extra data. That's all. So during the cross communication, the super app needs to add strict security policies. So when two mini apps are communicating, so it is a duty of the super app to impose strict security policies so that the data is protected between the two mini apps, so that data is secure while the communication is going on. For example, if I give you an example, WeChat has enforced mandatory HTTPS protocol for mini apps to communicate. So what happens is when the mini apps wants to communicate, they can only communicate through HTTPS. If the channel is not HTTPS, they won't be able to communicate. So that's how the super app can impose different policies or implications on the mini apps. But sometimes the communication is often mini app specific and how to be secure from super apps perspective. For example, there are few cases in which mini apps can communicate directly and super app is not aware about the whole situation going around. So what happens is mini app can talk to one app or another mini app by encrypted messages, and which is not regulated by the super app. So that's how things work. As finished proceedings. So we'll talk about it further. So the research objectives of this paper is the security and privacy, is how the mini applications are securing data, how they are transmitting data from one place to another, and how they are communicating. And while they are communicating, is it secure enough for a person to transmit data from one mini app to another? So is it possible to trust a mini application, basically a mini application communication? Other than that, we'll be covering about the web application security, how the security is maintained during the web application communication. We'll be talking about the mobile and wireless security also. Let's move ahead. Methodology. So here in this research paper, we have targeted different applications, but basically our main target will be WeChat and Baidu, because these super applications have many mini applications inside them. For an example, WeChat has approximately 25 lakhs mini applications, and Baidu has approximately 1,48,000 mini applications. We'll be talking about the figures further. So is it legal to attack these apps? We are not actually attacking these applications. After reading the developer's guide, we are just following a series of steps that we are going to follow. So yes, it is legal to attack these applications, but to attack, we are following certain regulations. So that we'll be discussing further. So if I talk about this research paper, this is one of its kind. This is the first research paper on Cross Miniapp Request Forgery that you'll find on the internet. So it is basically Cross Miniapp Request Forgery is basically it is basically targeting the mini application communication. So this is one of its kind. Even developers are not aware about the vulnerability. Yes, it is a kind of new kind of vulnerability that we find in the market. So not everyone is aware about it. Even if the developers are aware about it, they cannot do anything about it because it basically works on the security checks at the senders and the receivers end. So this is basically the vulnerability from receivers end, that the receiver has to verify the source of the data that the application is getting. So that's how things work. So complicated, yes, it is basically a complicated process, and it is a new concept for developers also. So that's why this vulnerability has not been patched since then. So we are still waiting for a patch. And yes, there are many. So this vulnerability is basically based on the missing checks of the identity or app ID of the sender application. So what happens is, whenever a communication is about to happen with two mini applications, a global app ID is provided by super app to the mini apps. So one app send extra data, the data that they encapsulate, they encrypt the data that they like. One mini application wants to send some data to the other application, right? So what happens is, while transmitting data, we call that data an extra data, which includes the app ID of the first mini application. So the second application should be there to verify the source of the data that it is getting. If it fails to do so, if it fails to verify the global app ID of the first mini application, then we call it a vulnerability. Cross Miniapp Request Forgery is this concept only. So what we do is, we develop a new kind of request from an unauthentic source, and we send it to the second application. And the second application does not verify the source, and it processes the payment or whatever we want it to do. So that's how it works. So the key concepts, before understanding the whole research paper, every concept, I would like to refresh all the concepts in very brief. So first I want to talk about the mini apps. So mini apps are basically the services, the mini application services inside a super app. So it could be like, we could have a lot of mini applications inside the super app. It is light in weight. It is fully, it works fine, just like the super application, but yes, it is light in weight and the development cost is much lower. The super application is basically the fully fledged app that we run. It provides different services in different domains. Then we have the host application. The host application is basically the application which provides the runtime environment for all the mini applications. So super app is basically a mixture of mini application and the host applications. Then we have input validation. Input validation means that whenever an input is received by any of the application, it should validate the input and the source and the syntax. Then we have the missing checks. Suppose there are two applications and we are like, the first application is sending some extra data to the second application. Then if the second application is not verifying the source, the app ID and the global app ID, then we call it a missing check from the at the mini application level. Then we have the front end and the back end of the application. Front end is basically the UI UX of the mini application. So it basically whatever we see. The backend is the server. We don't usually have servers in mini application communication, but we usually communicate using different kind of APIs. So let's move ahead. So we have mini app communication. Why is it required? Mini app communication. So I'll give you an example. Suppose we have a shopping application and we want to buy something from the internet. We select something, we put it in our cart. Now we want to buy. So before buying, we'll have to make a payment. So like for buying, we need to make a payment and it needs to verify whether it has received a payment or not. So we are on a shopping application. We'll place the order. It will redirect us to another mini application for the payment. Once we do the payment, once we make the payment, the second mini application is going to transmit extra data. It is going to tell the first application that yes, the application has received our payment, so it can send us the order details. So that is why the communication between mini application is required, because they are providing different services at different time, so they needs to communicate. Yes, cross communication is also like possible inside the mini application. We call it the mini app cross communication. But to cross communicate, they need to use the global app ID. Sometimes it is possible that the second application or the first, like whichever application is getting the data, it is not verifying, it is not like doing security checks. If it is missing, if there is missing checks, then it is highly probable that the application is vulnerable to Cross Miniapp Request Forgery. So in some cases, we'll call it a global app ID. In some cases, we'll call it an app ID. In case of WeChat, we call it app ID. In case of Baidu application, we call it app key. So these are basically the variables that we give. These are basically just the variables inside an application. So we are calling it as it is basically the ID which is generated by the super app or the mini app. So that it can identify the mini applications. So this is like, here we are going to talk about the resources. In the table, we can see, like, depending on the location of the resources, it is guarded as shows in the table. Obviously, our super app guards the whole application because it is the whole application. It has many applications inside itself. So obviously, it is going to protect the resources, but depending on the location of the resources, it is guarded. So we basically have front-end guarded resources and back-end guarded resources. So as you can see in the table, for front-end, the locations that we are mentioned on the front end, so we are going to guard them in the front end guarded resources, and the services which we have in the backend resources, we are going to guard them in the backend servers. So that's how, like, that we are talking about the location, the audio, the Bluetooth, the camera, the media. So if we are talking about these things, obviously front end guarded resources, these are front end guarded resources, so we'll be taking care of them in the front end. And if we are talking about the payment, because these are basically the things which we do not share with the user. So these are the things which are working on the backend. So we'll be talking about them, we'll be like guarding them in the backend only. So now we'll be talking about cross mini-app communication stages. So basically, when a cross mini-app communication occurs, it basically occurs in different stages, as we can see here. So here, like, all the functions depict are different stages of the process. So here we have the sender mini application. So here we are talking about the WeChat application. It is basically a chatting application. So here is the sender mini app. Here is here we have the receivers mini app. So it has its backend and the front end. Receiver mini application is also having its front end and the back end. And this is the WeChat main process. So what happens is, sender mini application is going to generate a request ID and the app ID from its side. Like, the WeChat application is going to create the request ID and app ID for the sender mini application. And all these functions will take care. All these functions will happen. And after that, once they reach the front end of the receiver's mini application, they are going to verify it. If this verification step is missing at any stage, then in that case we can say that it is vulnerable to Cross Miniapp Request Forgery. So sender sends the request and the application ID, which is verified at the receiver's end. And if, I'm telling you again, if this verify app ID is missing, then we call it it is vulnerable to Cross Miniapp Request Forgery. Let's move ahead. So now we'll be talking about the CMRF attack. CMRF stands for Cross Miniapp Request Forgery attack. So I'll be discussing about few assumptions with you. There are few assumptions that we follow. If I talk about it, like, let me show you. So basically, this is the table that we were talking about, the table of the summary of resources and their protection mechanism. First, we talked about this. Then we were talking about the cross app mini communication. So now I'll be telling you about the attacks. So there are few assumptions that we think from our side. First assumption is that our application is, the application code that we are analyzing is safe and it is not tampered enough. So we assume that the application that we are using is free from tampering and it has never been tampered. This is the first assumption. Second assumption is the mobile phone application that we are doing this attack on, the mobile phone that we are using is using the original OS. It does not have the forged or the root OS that it is using. So these are the two assumptions that we follow. So basically, no tampering with host app code or the front end of the mini application is done. Then the backend we are also trusting the backend of the mini application. These are basically the assumptions that we follow here. And one more final assumption is that phone is trusted, but the sender mini application itself could be trusted. The phone has the original operating system from its vendor. So these were the assumptions. And yes, attacks are easier on mini application. There are two reasons basically. The first reason is the attackers does not have to publish the application in the market. Suppose an attacker wants to attack a mini application. So to attack a mini application, we don't have to publish another application in the app store. We can directly host a mini application and directly we can throw an attack. After that, even when attackers submit a malicious mini app for the inspection, the super app cannot guarantee to scrutinize this mini app as a cross communication in mini application. So even if we submit a malicious code in the mini application, it is not going to verify that code. For example, if we send a malicious code on Gmail, instantly it is going to remove that code because it is going to verify the code itself. But in case of mini application, there is no security check, so there is no one is going to verify the application, the code that we are sending. So that's why it is way easier to attack a mini application. So if we talk about the threat modeling is done based on the proof of concept. Proof of concept means the researchers of this research paper have, like, they have read the developer's guide for the WeChat application and for the Baidu application. They have thoroughly read the developer's guide and found that there are so many security checks missing inside the mini applications. So that's how they did it. Then we'll talk about the reverse engineering. Obviously, reverse engineering can be done when the two mini applications are in the communication stage. We can reverse engineer to get the data from the first application. So we'll be talking about it further. And yes, we can notice that the app ID is so fundamental here that at every stage we verify the application ID. But this is the main flaw in the mini application code. The developers forgot to check this application ID every time. So this is why we are facing this problem. So there are basically two types of attacks that we can perform on a mini app. First is CMRF for data manipulation. So here we can manipulate the data that we are sending. For example, we are sending for example, we are not making a payment. There's a payment application and a shopping application. So what happens is we are going to manipulate the data and we are going to trick the first mini application that we have done the payment when we have not done the payment. Like, we haven't done the payment, but we are going to manipulate the data so that we can trick the first application into thinking that we have made the payment. So that's the first kind of attack that we can perform. Then for the second attack, it is CMRF, Cross Miniapp Request Forgery, for data stealing. Suppose someone is entering his or her credit card details. You want to steal those details, or suppose there is some sensitive information, the government ID of someone that we need to steal. So we are going to send a request to the second application, the second mini application, and what it is going to do is it is going to revert us with the sensitive data of that person. So that what we can do is we can do the data manipulation or we can steal the data. So vulnerability detection method, we are going to talk about it. So identifying the missing checks. So basically here we are talking about the missing checks. It basically means when the first mini application and the second mini applications are communicating, at every communication step, there should be a check of the application ID. If it is not checking the source, the authenticity of the data that it is receiving, then we call it a missing check. So to identify these kind of vulnerabilities, the first and foremost thing is we identify the missing checks inside the code. After that, detecting uses of cross mini-app requests. Obviously, we need to detect the users of cross mini-app requests, the users, how many users are using it at one time. If it is not checking the authenticity of the user, then that is highly probable. The probability is very high that the application is forged or vulnerable. The researchers of this research paper have created a CMRF scanner tool. So this is basically a JavaScript tool that they have developed to find a vulnerability inside an application. So I'll show you that we have talked about everything that I'm talking about. So this is the we present CMRF Scanner, a JavaScript static analysis tool that utilizes the abstract syntax reconstructed from Miniapp to scan for vulnerable Miniapp. So CMRF Scanner, this is a tool that they have developed. So it is based on abstract syntax tree. So what this tool does is it is going to form a tree. It is going to read the code first, the developer's code, then it is going to create a tree based on all the functions which are mentioned in the tree. Then it is going to mark green and blue nodes. So it is basically going to mark all the points where we need to implement, where we are missing the security checks. And just in case we need that, we can implement the security checks and make our mini application strong enough. So this is how the AST tree basically looks for. So this is how the AST tree looks like. These are basically the functions inside the developer's code. The logic express, the call express, binary express, conditional express. So these are basically all the nodes of the code that we are having. So that's how the CMRF scanner works. Obviously, we cannot trust this scanner fully, but I'll talk about its false positive and false negatives further in the presentation. So the implementation of the attack was so simple that they just focused on the proof of concept attack code by following the developers documentation. So they followed the developers documentation and performed all the steps which were written there. They found that the missing checks were not there at many stages for many applications. So they basically focused on the WeChat application and the Baidu application. That's why I'm talking about them. So if I talk about, like, in this paper, they have implemented proof of concept attack, as well as by doing reverse engineering on the mini applications. After this, they also created a fake payment status and injected message to the mini app. Basically, a tool named as XX was used by them, detecting. So this is how the AST2 basically looks like. If I talk about the implementation, here we are talking about, we have implemented the proof of concept code by following the developer's documentation. The code for the CMRF scanner is also visible. If someone wants, like, he can check the Git repository. I think it's time to stop the presentation here only. But as I told you, this is the full and foremost summary that I have given in this presentation. So these were the topics that were left. The filtered, all the application will do not contains. So to make their attack efficient, they filtered all the application which do not contain the cross application. Scan was done based on extra data that was being transferred, so that it is efficient for the scanner to perform all the security checks. So these were some attacks that they performed: the shopping for free attacks, device manipulation attack, promotional abuse attacks. As the name suggests, shopping for free attacks is they placed order using using this attack. Then they did the device manipulation. They did the manipulation with the Bluetooth this location settings. Then the promotional abuse is they applied many promotions. So for example, they created fake coupons and they did shopping with them. So these are top 5 Cross Miniapp variable names. So these are highly vulnerable. They found that these variables are highly vulnerable. So if someone is using them, they need to take care of these variables. So this is another researcher who performed the system architecture and key technology used by WeChat mini apps. He performed a research on this topic. So if someone is interested, like, we can have a look on this only. So regarding the mini application, it's solely based on the mini application. So the conclusion of the research paper was to understand, like, how popular the mini apps are vulnerable to attack. They developed a CMRF scanner, which has identified approximately 52,394 WeChat mini apps and 494 Baidu mini apps that have used mini app communication, out of which approximately 96% of WeChat mini application and approximately 99.8% of Baidu mini applications are subjected to CMRF attack, which is way too much. So among all those applications that do not validate app ID, so none of them were validating the app ID. So there are basically a lot of applications with such vulnerability. So my reference point was this research paper itself. This is the link for my research paper, this research paper only. Thank you so much.